Hello and welcome to lesson 9. Today we're going to talk a little bit about absolute value. And we did talk about this a little bit when we were talking about inequalities before, but because some students will be in different places and because we want to take a closer look at solving more complex inequality, or not inequality, more complex absolute value questions, we're going to go ahead and do some more of these. So in case you're not familiar, absolute value is just, I'm going to switch over the board. Absolute value is the idea of distance from 0. So if I put -5, that is going to be equal to a value of 5 because on a number line, so here's 0, here's -5. -5 is the same distance away from 0 as +5. They both have a distance of 5. So at the end, whenever you have a single number, that number is just the positive version of the answer, which leaves us in a bit of an interesting situation whenever it comes to solving an actual question. So if I have something like x plus 3 equals 5, well, normally I'd just subtract 3, it'd be 2, I'd be done. But with absolute values, there's actually two forms of this equation I have to do. I have to do x plus 3 equals +5, and I have to do x plus 3 equals -5, because -5 would also be a valid solution in this case, because if I had -5, absolute value of -5 would also be 5. The logic would check out. So in this case, I'm still going to subtract 3. So, -3 minus 3. So x does equal 2. 2 is a valid answer, but I also need to subtract 3 over here. So -5 minus 3, that'd be -8. So x would equal -8. So here I'd have both the answer -8 and +2. So this is the challenge we run into when we are solving absolute value algebraically. Now I'll do one more that's a little bit more complex so that you can see kind of where all of this comes to a head. So let's say we've got 3 absolute value of x minus 4, that is absolute value, plus 2 absolute value of x minus 4, plus 3 equals, let's say 9. So first and foremost, we can go ahead and subtract 3. I think that's probably the easiest one here because it's not inside any of the absolute values. So we have 3 absolute value of x minus 4 plus 2 absolute value of x minus 4. And that is equal to 6 because, 9 minus 3 is 6. So what are we going to do here is these are essentially the same number. So I've got 3 of the number and I've got 2 of the number. So altogether, I have 5 absolute value of x minus 4, and that is equal to 6. So now what I got to do is I got to divide both sides by 5. And you'll notice that I haven't split the absolute value equals up yet. That's because I need to get the absolute value by itself before I can actually solve for it. So over here, so 5's cancel, and I'm left with absolute value of x minus 4 equals 6 over 5. So this is the point. This is the point right here where I would split this up into 2 questions. So you saw how I was doing the algebra normally as if there had just been parentheses. I could have done that with parentheses. But because it's absolute value, I need to get this whole term by itself before I can start splitting it up into multiple different problems. So now I could say x minus 4 equals positive 6 over 5, and I can say x minus 4 equals negative 6 over 5. So from here, I would add 4 to both sides, so plus 4 plus, oh, that should be 6 over 5. Did I write 6 over 4? I did write 6 over 4. Okay, we're gonna fix that. Not sure why I put that 4 there. That was supposed to be a 5, silly me. If you spotted that before I said anything, you earn 5 brownie points. So we're going to add 4 to both sides. So plus 4, plus 4, plus 4. And if you remember the fraction stuff, 4 over 1 would be the same as 20 over 5. So x is equal to, so 20 plus 6, that'd be 26 over 5. And x is also equal to, so we'd be still adding 20 over 5. So negative 6 plus 20, that'd be 14 over 5. So our 2 answers in this case would be 26 over 5 and 14 over 5. If you wanted to write those as decimals, you can, but we're going to leave them as fractions for right now. So this would be how we would do absolute value if it gets a little bit hairier. So that is going to be how we do that. So I'm going to erase the board. Let's go back to the lecture for a second. Okay, so we're back here. Okay, so two possible solutions, positive and negative. We've talked about that a little bit before, and I just went over it now. So when graphing absolute function, okay, so actually graphing it is a little bit strange because, as you've seen from the graphs we do, it does a bit of a right angle whenever we do this stuff. Now, we do have the option of just plugging in x values and seeing what our y values are. As I said before, when we were talking about graphing initially, you can always do that to figure out what your graph looks like, but let's look at how to actually read an absolute value graph. So let's say we have a brush. So let's say f of x is equal to the absolute value of x minus 3. Okay, so that means the lowest that this possibly can be would be 0. So x minus 3, absolute value's lowest value is going to be 0. So that would just mean x minus 3 equals 0. So if x is 3, so if I have an x value of 3, the y value would be 0. So let's go ahead, pull this up on a chart. So I'm going to move to the right 3. And now I'm going to do something a little bit interesting. So this graph is actually going to be two graphs. So the first graph is going to be x minus 3. So that is what we're going to have after x equals 3. So we're going to split it over this line right here. So after x is 3, we're just going to go up from there. We just go up from there using 1 as our slope. So we go, right 1, up 1, right 1, up 1. That's just the way that works. Meanwhile, before x minus 3, we're actually going to multiply both of these guys by negative 1. Not negative 7, negative 1. So that would leave us with the function x minus, 3 minus x. So basically you swap these around. So that would mean that as I go left, I go up 1, left 1. So it's that nice little V shape. So basically, if x is less than or equal to 3, I'm going to do this. I'm going to do this 3 minus x chart. But if x is larger than or equal to 3, I'm going to do this positive, x minus 3 chart. This would be how you would chart it in your mind. So over here, so across this dotted line, over here, we've got 3 minus x. And over here on the right side, we've got x minus 3. So that would be how it splits over the absolute value. And this isn't the only function that exists that's going to be what we call split. Basically meaning that on one side it does one thing, on one side it does the other. But in the middle it happens to do both. So in the middle we're just going to get the y value equals 0, which is fine. That happens. And remember, we can find where y equals 0 by just setting it equal to 0, solve it, we'll get that x value. So let's do one more of these before we continue on to talk about some other stuff. So let's start with f of x is equal to, let's say it's 3x, let's say plus 12. Okay, so we got 3x plus 12 equals 0. So, minus 12, so negative 12 is equal to 3x. So that means x would be, so we divide by 3 on both sides. So negative 12 divided by 3 is going to be 4. Negative 4, because keep the negative. So we're looking at negative 4 over here. So negative 4 is going to be, boop, 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 boop. We'll say it's there. So x equals negative 4. So we know that the y value is going to be 0 at that location. So now we got to do this guy flipped around. Okay, so we'll do the positive version first. 3x plus 12. Okay, so we go over 1, up 3, so over 1, up 3, all the way off into the distance, shoots way up into the sky. Okay, so now let's go ahead and do the negative version. So the negative version, we're going to have negative 3x minus 12. So we're starting here, so we go left 1, up 3, like this. You'll notice that these two are really just mirrors of each other. So if you can do the right side, you can get the left side just by, doing the, by going left instead of right. So if you go left and go up, by the same amount that you went right and went up, you can graph this either way. So absolute value functions are kind of nice in that way that they are what we call symmetrical about a specific line. And you can always find that specific line by just setting the inside equal to 0. Okay, so with that in mind, we're going to clear off the board, and then we're going to go ahead and switch back over to the presentation so we can see what else we got to look at for today. Heading back. So that's how you graph an absolute value function. So after this, we're going to be talking about something called piecewise functions. So just in the same way that the absolute value function does something different depending on what x is, piecewise functions do that as well. But that's going to be for the next video. For now, I'm going to leave you here on this lovely little word problem that we have. That's going to be what we go over in the synchronous session. So I hope you enjoyed. I hope you have a good day until I see you in the next one. So bye-bye.